All right, Algebra 2, here we go on 4.2. We're going to learn all the things that we need to know about graphing quadratics. So, specifically graphing quadratics in standard form. Standard form is when you have all of your terms being added or subtracted together. You shouldn't see any parentheses in there. So, we need to be able to find the vertex. That's one of the big ones. And there's a formula to go with that for standard form. And so it's right here. I'm going to go negative b, so we're going to have a negative 1 out here times whatever our b is, divided by 2 times whatever our a is. So notice those would just be our coefficients. A is always linked to x squared, b is always linked to x, and then c is always alone without a variable. So once I find the x value, that gives us the axis of symmetry, which is just the center point of our parabola. So that's going to cut our parabola in half. But that will only give us x. So then in order to get y, our other half of the vertex, just like we've been doing all year, if I have an x, I'm going to plug it in and we'll get back y. So there's going to be an opening up parabola and opening down parabola. This happens when a is positive. So think this creepy little smile right here. You get a creepy little smile because you're positive. And then you get a creepy little frown right here when you're facing down. All right, when you're feeling a little bit more negative. These eyes are a little off. All right, so we kind of can find that from our a value. So we would look up front in our a value, whatever's linked to our x squared. If it's positive, we would open up. If it's negative, we would open down. So let's kind of see how that looks here. I'm just going to pull my a, b, and c first off. So when I look at this equation, I'm going to pull a is 5, b is negative 20. Make sure you keep the signs with it. And c is positive 20. So if I want to find min or max, I can do that first, and that's quick. So we look at if a is positive or negative. Well, a here is positive, so we're going to be looking at an opening up parabola because of that. So that will have a low point, a minimum. All right, now let's move on to the next part. We have to find the axis of symmetry first, which is just the x value. And then we use that x value to find the other half, our xy point. So remember, our equation is x equals opposite of b over 2 times a, or negative b. All right, so I have b right now as a negative 20. So I would have negative 20. So the second negative makes a positive. All right, so opposite sign. I was negative, now I'll be positive. All over 2 times a, which is 5. So then we'll get 20 over 10, which simplifies to 2. So x equals 2. That's our x value right there, using that formula. So then when I want to find y, I'm just going to take that x and plug it back into our equation. So here we have x's here and here. So we'll find y by doing 5 times x squared minus 20x plus 3, but now we know that our x is 2, so I plug that into both. That gives us our y value, so you'll put that all into your calculator, let that do the work for you. There's negative 17. There's our y. So the vertex is that full coordinate, 2, negative 17. And remember, guys, the vertex means this point right here, that lowest point as the minimum or the highest point as the maximum. All right, let's check out example 2. So example 2, let's set up our A, B's, and C's. A here is 1. Remember, if there's not a number out front. B is supposed to be linked to x, but I don't see an x, which means it's plus 0x. So B is 0. And C right here, positive 10. All right, so because A is positive, again, we're looking at a minimum because we're opening up. And then we'll go ahead and take our axis of symmetry formula, negative b over 2a. My b here is 0, so negative 0 is not really a thing. We're still looking at 0 over 2 times 1. Well, if you divide 0, you'll always get 0. All right, so our axis of symmetry here is 0. And so then remember, guys, we want to find the other half because our vertex, we've got one half of it, and now we just need to plug it back in. So y is going to be equal to 0 squared plus 10. There's no other x's there. 0 squared's gone, so we know y here is going to be 10, giving us that other half of our vertex. All right, so let's talk about the y-intercept. We've talked about what that looks like on the graph. Algebraically, we've talked about that as well. You'll always have a y value with x being 0. Just like on your x-intercept, you'll have an x value with y being 0. So if I know x, just like we did, we would plug in 0 for x every single time we want to find the y-intercept because x will always be 0 here. So when I look at this example 3, if I want to find the y-intercept, I know x is 0, and then we'll find our y. So we're going to go through and replace all x's with zeros. And you'll throw that into your calculator, and you will get negative 6. All right, so my y-intercept here should be 0, negative 6. All right, so you guys try this one again. Check your work with me here in a second. So we're going to plug in zeros. Plus 4 times 0. Some of you guys might be finding a pattern here pretty soon. You're looking at a 2. So 0, 2 would be our y-intercept here. All right, let's check these notes out. Increasing, decreasing, we've already worked with that this year. It's just saying, hey, as the x values are increasing as I go to the right, the graph goes up. And if the x values are increasing as I go to the right and the graph goes down, we're looking at increase, decrease. And then again, ending behavior, rising or falling, we've done some work with that so far. As I go to my left end behavior, is it going up or down? As I go to my right end behavior, is it going up or down? And zeros, there are 3 different ways that you can have zeros. It's how many times the graph touches the x-axis. So you might have a parabola not touch that 0 or that x-axis at all. So you'd have no zeros. In this next example, you might just have it touch at one place and it bounces off of the x-axis. So there you would have 1 0. And then, of course, our last example here where we cross twice. Now, there will never be any more than 2 zeros with a quadratic. So let's go ahead and put this all together and see what we can do here. What we've learned today is standard form, so this will be standard form. We have not learned factored form, which is why that has an NA, not applicable. All right, so this will open up because A here is positive. A is a positive. So because it's, A is negative, so this is going to open down. I don't even know what I was looking at that point. Opening down. All right, A is negative. So we'll open down. So when we open down, that's going to give us a maximum. All right, so then we can look at our axis of symmetry. So I'm going to say A here is negative 2, B is 4, and C is negative 5. So we'll do our axis of symmetry equation, which is x equals negative b over 2a. So negative b, so we'll look at negative 4 over 2 times negative 2. Negative 4 over negative 4. So x in this case, is going to be equal to 1. So now I already know in my vertex x is 1. I just need to find the y. So I'm going to go ahead and plug it back into that equation up here. So we will have y is equal to negative 2 times x squared plus 4 times x minus 5. And our x here is a 1. So once I put this into my calculator, you guys are going to get the answer of -3. So let's plot a couple of these things. Let's at least plot the vertex here, 1, -3. And I know it's a parabola that's facing down. All right, so I know we're looking down like this. So let's see what else we can find information-wise. End behavior as I go left, it's opening down on both, so they're both falling. In a quadratic, they're always going to have the same pattern on end behavior. All right, let's find our y-intercept here. So we know y-intercept will plug in a 0 for y. So we will have -2 times 0 squared plus 4 times 0 minus 5. So you should get a -5 here. So let's plot that. -1, 2, 3, 4, and 5 right here. Parabolas are always symmetrical, and they're going to be symmetrical around that vertex. So that means that I can mirror this point across my axis of symmetry, which brings me right here. And these are really my main 3 points I'm going to be looking for. So now I'll draw my parabola. It's a good looking graph there. All right, number of zeros. Not asking for what the zeros are, but in this case, not any. Okay, we're not touching that x-axis at all. And then domain and range is a review for us. So -infinity, left bound to right bound. Range, low to high. So we're going all the way down into the negatives here. But we stop at this point right here, which is a y value of -3. And you'll always be able to pull that y value from your vertex. Oops. How about that? All right, increasing, decreasing. So I increase from here to here. All right, so remember I look at x values. So I'm going from the negative infinities on the left all the way to 1 is where I stop increasing. That's our x value. And you guys can find that in your vertex as well. That's that turnaround point. All right, and then it turns around and starts to decrease. So we would decrease from 1 to our positive infinities. All right, you guys, I hope that helped. Ask questions where you have them, and good luck.